Hello everyone, my name is Amit Kumar Mohanty. I'm an educator at Mentor for you. So in today's challenge, it is a particular part of a geometric challenge because previously we have completed questions regarding summation, integration, all of these particular topics. So now I think it will be a good idea to get our hands-on experience with a geometrical question. Now let's go to the particular question. In the question, it is given that a chord AB of an ellipse x square by 9 plus y square by lambda square equals to 1 subtends a right angle at the center of the ellipse. Clear? Center of the ellipse is origin in this particular case, which is denoted by O. Now, also what is given in the question that 1 by OA square plus 1 by OB square equals to 14 by 45. Now, what is this OA? OA is the distance from origin to the particular point A. And what is OB? It is the distance from particular point origin to the particular point B. And what is AB? AB are the particular chord that is intersecting this particular ellipse. Clear? So let's proceed to the next step. Before proceeding, we need to have this idea that to have a better understanding of the question, it's better to have a what? Better to draw the structure or a particular diagram that will help us to visualize how to solve this particular question. Now, keeping this in our mind, let's proceed to the next part. So you can see this is a particular structure of our ellipse. Now, remember in this particular ellipse, the center, or you can say the origin, is the center for this ellipse. Now, let's understand few facts with this. Let's say this in this particular ellipse, let A be the particular chord. You can see, yes. So what is AB? AB is the chord which is intersecting the particular ellipse. Now, from the particular question, what we have known that the ellipse, the chord subtends a right angle at the center of the ellipse. So if the ellipse looks something like this, it will denote a right angle at the origin. You can see this angle is 90 degrees for this particular part. Clear? So if I just remove it, I think for better understanding. Now, let's say what it is given. If this angle is 90 degree, let this angle be θ1 and the other angle be θ2. Now, with this particular thing, first what do we need? Let's this particular length OA be R1. Clear? Now, what will the coordinate of this particular point A? If this is a particular ellipse, then any point on the ellipse, before rather going to any points on the ellipse, let's use the distance and find the angle. Using the distance and the angle, let's find the coordinate of the particular points. Now, with using this particular relationship, let's find out. So this length will be R1 cos θ1, and this one will be R1 sin θ1. Using this type of relationship, what we can do, this is the x coordinate is R1 cos θ1 and R1 sin θ1. Clear? Now, let's find the coordinates of the point B. With the coordinates of the point B, what we know, the length of the particular O to B is R2. What is R2? The length from O to B. Now, so with this particular concept, if this angle is θ2, what will be the x coordinate? It will be R2 cos θ2 and the y coordinate will be R2 sin θ2. Clear? So what do we know? Till now, we have found the particular coordinates of this particular point, which is R1 cos θ1 and R1 sin θ1 and R2 cos θ2 followed by R2 sin θ1. Sorry, θ2. Clear? Now, in this particular next question, what are the relationships that we can understand? You can see this particular point that we find out, A and B, both are lying on the ellipse. Or in other words, what can I say? They both satisfy the equation of the ellipse. Clear? With that understanding in mind, let's put this particular equation into the particular equation of the ellipse and let's try to find the relationship between them. Clear? Now, so before proceeding forward, let's understand the relationship between the two angles that we can derive so that we can have a better understanding. Because what we want, there are many variables in this situation, which is one is R2, R1, R2, and what are the next variables? Sin θ1 and θ1 and θ2. So first we need to, if we want to find our ultimate answer, we need to establish a relationship between θ1 and θ2. So according to in the question, what it is given, XOX, which is the straight line. Now, angle around the straight line is how much? 180 degree according to our straight line using that particular relationship. So let's try to write the angles. So angle XOXX is equals to 180, angle produced by a straight line. Then this angle can be written as how much? θ2 plus this angle θ2. This internal angle is how much? 90 degree. And the right side angle is θ1. So combination of all these three angles, θ1 equals to 180. So combination of all the three angles is 180. If I take the 90 on the right hand side, what is the relationship that I'm getting? θ2 plus θ1 equals to 90 degree. Clear? I hope this was clear. Now let's proceed to the next step. So you can see we have also done the same particular thing here only. Straight line, we found the angle as θ1 plus θ2 equals to 90 degree. Now, what we want, we have to put the particular points that we have found out with their x and y coordinates into the particular equation of the ellipse. So let's put the particular points. So one point is what? R1 cos θ1 and R1 sin θ1. Let's put in coordinates of x and y. So this will be R1 cos θ1 whole square by 9 plus R1 sin θ1 whole square by lambda square equals to 1. Now let's take this R square to the right hand side by taking, let's first take R1 square as the common from both the terms and let's divide the R1 on the right hand side. If I follow that, the equation will look something like this. Yes, cos theta 1 whole square by 9 plus sin theta 1 whole square by lambda square equals to 1 by r1 square. Clear? And what is r1? The distance between O to A. So I can write it also as 1 by OA square. Clear? Now, let's apply the other particular point, which is r2 cos theta 2 and r2 sin theta 2. Now, in this particular, similarly, what you can see, the equation will be r2 cos theta 2 whole square by 9 plus r2 sin theta 2 whole square by lambda square equals to 1. Now, same thing that we have to follow. We have to take r square common from both the terms and divide it on the right hand side. If I'm following that particular logic, what I can see, the equation will be cos theta 2 by 9 whole square plus sin theta 2 by lambda square equals to 1 by r square, which is equals to 1 by OB square. Because what is r2? r2 square. R2 is the distance from O to B. So it will be 1 by OB square. Now, according to our relationship, what we know, theta 1 plus theta 2 equals to 90 degree. That means theta 2 equals to 90 minus theta 1. Clear? Now, what we can do, we can replace the theta 2 in every equation that we found in the equation number 3 with how much? 90 minus theta 1, because theta 2 is 90 minus theta 1. So if I write this particular equation, what will my new equation look like? Cos 90 minus theta 1 whole square by 9 plus sin 90 minus theta 2, theta 1 whole square by lambda square. So cos 90 minus theta is sin theta. So it will be sin theta 1 whole square by 9 plus sin 90 minus theta 1 is cos theta 1. So it will be cos theta 1 whole square by lambda square, which is equals to 1 by OB square. Now, with this particular relationship, remember the first relationship that was question given us in the question, it was given us that 1 by OA square plus 1 by OB square equals to how much? 14 by 45. This was given us in the question initially. And what was our question helping us to do? My task was to find the value of lambda square. Clear? Now let's use this particular relationship. So this is 1 by OB square. Yes, and this is with that next relationship, that is also 1 by OB square. So let's add it both this equation and let's equate it to 14 by 45. Clear? So in this particular equation, you can see we are performing the same particular thing that I have mentioned right now. What are we doing? We are adding all of those equation 3 and equation 1. You can see here in this particular equation, it is equation 4 and equation 2. As a result, what will happen? So there is one particular term which is sin theta 1 whole square by 9, and another term from the equation 4 will be cos theta 1 whole square by 9. Clear? This cos theta 1 whole square was previously as sin theta 2 whole square. Now this sin theta 2 is converted into cos theta 1. For that particular reason, I can take 1 by 9 as common, and this term will be 1. So the particular term will be 1 by 9. And the rest terms are 1 by lambda square equals to cos square theta plus sin square theta. Same, using the same relationship. Now from this, what did I know? Cos theta square plus sin theta square, using our identity of trigonometries, the value is how much? 1. So after this, our updated equation is 1 by 9 plus 1 by lambda square equals to 14 by 45. Now let's take this 1 by 9 onto the right hand side. It will become 1 by lambda square equals to, let's multiply 14 by 45 minus 1 by 9. So multiplying 5 on numerator and denominator, it is becoming how much? 14 by 45 minus 5 by 45. And this is ultimately 9 by 45. And if I try to reduce this, it is 1 by 5. So from the relationship, what did we find out? 1 by lambda square equals to 1 upon 5. That means lambda square equals to 5. And this is our answer that we were looking for. Clear? I hope this was I was able to make this particular question clear for you. And if you need the PDF link of this particular question, do let me know in the comments, and look for the description. I will leave the PDF link as well as there. Now, you can, if you want to schedule a class with us or book a demo session with us, you can call us at this particular number, or you can drop an email ID, email at mentor4u2024@gmail.com. With that, I am giving a goodbye. Thank you. Take care, and we will meet in the next class. Thank you.